Every time you change your mind, you are obeying a hidden rule. You may never have noticed it. It works beneath your thoughts, quietly, the way your heart keeps its rhythm without being asked. But it is there, a single, elegant pattern that decides how a belief shifts when the world hands you something new. And here's the strange part. That same rule was written down more than 250 years ago by a quiet country minister who never showed it to a single soul. It was found among his papers only after he had died. Tonight, that rule has a name. We call it Bayesian thinking. And though it began as a few lines of ink in a forgotten notebook, it has since slipped into nearly everything. It hides inside the filter that guards your inbox. It guided the searchers who found a lost submarine miles beneath the sea. It steers spacecraft through the dark between worlds. And some scientists now believe it may be running this very moment inside the soft machinery of your own mind. So tonight, let it carry you. There is nothing to solve here, nothing to remember, no thread you must hold. Let your shoulders soften. Let your breathing slow. Let your eyes close whenever they are ready. We are simply going to wander together through one beautiful idea, the quiet rule behind how anything, anywhere comes to know the world a little better. Right now, in this quiet moment, you are not seeing the world. You are seeing a guess. It feels nothing like a guess, of course. The room around you, the soft light, the weight of your own body against the bed, all of it arrives so smoothly, so completely, that it seems to simply be there, waiting for you to notice it. But that seamless world is not flowing into you through your eyes the way water fills a glass. It is being built from the inside by your brain. Here is what is really happening. Light falls on the back of your eye, and your eye sends a stream of faint electrical signals up into the dark of your skull, where your brain sits in total blackness and total silence, never once touching the world directly. It has never seen a sunset. It has never felt the wind. All it has ever received are these flickering signals, vague, noisy, incomplete. And from that thin trickle, somehow, it conjures the whole shining world you live in. It does this by predicting. Your brain is not a passive screen waiting for pictures to land on it. It is far more like a storyteller who already has a guess about what comes next, and is constantly checking that guess against the faint signals arriving from your senses. It expects a face to be there, and so you see a face almost before you have truly looked. It expects the floor to be solid, the ceiling above, the room to hold still, and so it paints all of that in, instantly, filling the gaps with its best expectation of how the world tends to be. You can catch this happening if you know where to look. There is a small blind spot in each of your eyes, a place where the nerve leaves and no light is sensed at all. A gap in your sight wide enough to swallow several full moons. You have never noticed it. Your brain simply paints over it, smoothing the wallpaper across the hole so confidently that the emptiness feels like seamless wall. In the same way, only a tiny patch at the very center of your gaze is truly sharp. Everything else, the edges of this room, the corners of your vision, is far blurrier than it feels. The richness, the fullness, the sense that the whole scene is crisp and complete. Much of that is your brain's quiet invention. You hear it too. Think of the times you have caught your own name across a noisy room or heard a friend's voice in a crowd before you could possibly have made out the words. Your brain was leaning forward, expecting, filling the muddle of sound with the thing it was already half listening for. The same is true of a familiar song heard through bad speakers, where you understand every lyric, not because the sound was clear, but because you already knew what was coming. There is a name some scientists give to all of this. They call the brain a prediction machine, and they describe what you experience as a kind of controlled hallucination, a waking dream that happens to be tied gently to the real world. It is worth saying plainly that this remains a leading theory rather than settled fact. The brain keeps many of its secrets still, but the evidence has grown strong enough that serious researchers now speak of perception not as a clear window you look through, but as a painting you live inside, a painting your brain is always quietly correcting. And that is the heart of it. When the world matches the guess, you feel nothing unusual. You simply see. But when the world pushes back, when something arrives that the prediction did not expect, your brain feels the small jolt of surprise, adjusts, and updates the picture. A shadow that turns out to be a coat on a chair. A sound you were sure was a voice that softens into the wind. In those quiet moments, you can almost feel the machinery turning, the guess meeting the evidence and bending toward the truth. Think for a moment about what this means for the difference between seeing and dreaming. When you dream tonight, your brain will spin a whole world out of nothing, untethered and free. When you wake tomorrow, it will do almost exactly the same thing, spin a world out of its own expectations, except now the dream is held on a gentle leash by the light in your eyes and the sound in your ears. Waking life, in this view, is simply the dream that reality is allowed to correct. There is something tender in that. It means you have never once touched the world bare. You have only ever known it through your own soft, ceaseless guessing, a guess refined across a whole lifetime, shaped by every face you have ever seen and every room you have ever stood in, until it grew so accurate that it disappeared and felt like the world itself. So as you lie here now, let that thought soften you rather than unsettle you. The walls, the warmth, the quiet, your brain is painting all of it for you, lovingly, out of almost nothing, the way it has every day of your life. And as your eyes begin to close, the painting will not stop. It will simply turn inward and keep going in the dark. A test can be right almost every time and still be wrong about you. Imagine a small town, sleeping under the stars, 1,000 houses, 1,000 quiet lives. And imagine that somewhere in that town there is a rare illness. It is genuinely rare. Out of all 1,000 people, only one of them actually has it. The other 999 are perfectly well, though none of them know it yet. Now imagine a test for this illness, and a good test too. It is correct 99 times out of 100. If you are sick, it will almost always catch it. If you are well, it will almost always come back clear. 99% accurate. By any ordinary measure, an excellent test. One evening, you take it, and the result comes back positive. Your heart drops. The test is 99% accurate, and it says you are sick. Surely then, you are almost certainly sick, 99% certain, the number seems to scream. But here is the quiet, astonishing truth. You are far more likely to be perfectly healthy than ill. And to see why, you only have to walk gently through the whole town. Picture all 1,000 people lining up to take the test on the same night. Remember, just one of them truly has the illness. The test is good, so it almost certainly catches that one person. There is your single true positive. One sick person, correctly told. But now think about the other 999. Every one of them perfectly healthy. The test is right 99 times in 100, which means it is wrong 1 time in 100. And 1 in 100 of those 999 healthy people comes to about 10 people. 10 perfectly well souls who will also see the word positive purely from the small, unavoidable error in the test. So look at who is holding a positive result at the end of the night. One person who is genuinely sick, and around 10 people who are perfectly fine. 11 frightened people in all, and only one of them is truly ill, which means that if you are simply one of those who tested positive, knowing nothing else, your chance of actually being sick is not 99 in 100. It is closer to 1 in 11. Less than 10%. Sit with that for a moment, because it is genuinely strange. The test did not malfunction. It is exactly as accurate as promised. What fooled us was something we forgot to ask: how rare the illness was to begin with. When a thing is rare enough, even a small chance of a false alarm can produce far more false alarms than true ones, simply because there are so many healthy people for the test to occasionally trip over. This has a name. Thinkers call it the base rate, the background rarity of a thing, the way the world stood before any test was taken at all. And our minds are wonderfully, hopelessly bad at remembering it. We hear 99% accurate and feel certain because the number is loud and close and dramatic. The quiet fact that the disease was 1 in 1,000 sits far in the background, easy to overlook, and yet it is the very thing that decides the answer. This is not a riddle invented for its own sake. It is woven through real life. It is why a single worrying result from a screening for a rare condition is so often followed by a second, more careful test, rather than a diagnosis. It is why a good doctor, hearing of one alarming number, will often say gently, "Let us not be frightened yet." They are not dismissing the test. They are remembering the town, remembering how many well people there are for every sick one, and how easily a rare truth can be buried beneath a small pile of honest mistakes. There is a kind of wisdom hidden in this, reaching far beyond medicine. It whispers that no single piece of evidence, however strong it sounds, means much until you set it against the quiet question of how likely the thing was in the first place. A frightening result. A surprising claim. A coincidence that seems too sharp to be mere chance. Each of them feels certain in the moment, and each of them shrinks and softens and becomes bearable the instant you remember to ask how rare it would have to be. So let the worry in that imagined positive result drain slowly away. The town is still sleeping. Nearly every window is dark and untroubled, just as it always was. Out of 1,000 quiet houses, the truth was always only in one, and the night for almost everyone is exactly as gentle as it seems. The most powerful idea about evidence ever written down was found in a dead man's papers. His name was Thomas Bayes. He lived in England in the early 1700s, in the green and hilly town of Tunbridge Wells, where he served as a minister, a quiet, scholarly man by all the little we know of him. He preached, he studied, he kept up a correspondence with other thinkers of his day. And in his private hours, away from his congregation, he turned over a mathematical puzzle that almost no one else had thought to ask. Most people, when they think about chance, think forward. You know how a coin behaves, and you ask what it will do next. You know the dice are fair, and you ask the odds of rolling a 6. Cause, then effect. The machinery is known, and you predict what it will produce. But Bayes became fascinated by the harder, stranger question, the one that runs the other way. What if you can only see the effect and you want to reason back to the cause? You watch a coin land heads a few times, knowing nothing about it, and you ask, what is this coin? Is it fair or is it weighted? And how sure can I really be? Effect, then cause, working backward from what you can see toward what you cannot. This is the deep problem of learning itself, dressed in the clothes of mathematics. It is what every doctor does, reasoning from a symptom back to a hidden illness. It is what every detective does, reasoning from a clue back to an unseen act. It is in truth what you do every time you glimpse a small piece of the world and try to imagine the larger story behind it. And Bayes found a way to do it precisely. A method for taking what you believed before, folding in the new evidence, and arriving at what you ought to believe now. A way of turning a guess, gently, into a better guess. And then he did something that still feels almost unbearable. He set it aside. He never published it. As far as anyone can tell, he never showed this particular work to a soul, never announced it, never sought a scrap of credit for it. He simply finished it, or perhaps left it unfinished, and went on with his quiet life. And in time he died, in the year 1761, with the idea still sleeping in his drawer. We do not really know why. Some imagine he thought it too slight to be worth the bother. Some suspect he felt it incomplete, a sketch he meant to return to and never did. Perhaps he was simply a modest man who worked for the pleasure of the working, with no hunger to be known. The truth of it is lost. We cannot even be certain what he looked like. The portrait so often printed as his face may not be him at all. The man who handed us one of the clearest ideas about how to see the world has himself remained, fittingly, mostly in shadow. The idea survived only by an act of friendship. After Bayes died, his papers passed to a friend named Richard Price, another minister with a mathematical turn of mind. And Price, sorting through what his late friend had left behind, came upon the essay and understood almost at once that it was something rare. He cleaned it up. He added his own thoughts to it. And in the year 1763, 2 years after Bayes was gone, he brought it before the Royal Society in London so that it might not be lost. It was Price who carried the idea out of the drawer and into the world. Without him, it might have crumbled quietly into dust, and the name Bayes would mean nothing to anyone, anywhere, tonight. There is something that catches in the throat about that. Think of how many ideas must have died in exactly that way, finished or half-finished, set down in some private notebook, and then simply forgotten when the one who made them passed away. Whole insights, whole small revelations, gone without a trace, or one of a friend who happened to look through the papers and happened to understand. This one lived. By the thinnest margin of luck and affection, this one lived, and grew and spread until it touched very nearly everything. So tonight, as the name itself begins to soften and blur, picture that quiet study, a single candle, a pile of pages in a careful, fading hand, a man who worked something profound out of the silence, and then let it rest, asking nothing at all in return. And years later, another man's hand lifting those same pages gently toward the light, and changing without ever knowing it, the way the whole world would one day come to think. Somewhere on the floor of the Atlantic, a submarine lay lost, and to find it, the searchers first had to draw a careful map of their own ignorance. In the spring of 1968, an American submarine called the Scorpion failed to come home. She had been crossing the deep ocean, and then somewhere out in all that vastness, she was simply gone. No signal, no wreck in sight, nothing but a wide stretch of empty sea and the knowledge that she lay somewhere far below, in water miles deep and utterly dark. The ocean is enormous and a submarine is small. To search the whole region inch by inch could take a lifetime and might still turn up nothing at all. So the searchers tried something that sounds, at first, almost like a paradox. Rather than beginning with where they hoped the Scorpion was, they began by carefully laying out everything they did not know. They took the broad region of ocean where she might lie, and they divided it into a grid, like a great chessboard drawn across the seabed. Then they gathered the people who understood submarines and currents and the last few scraps of evidence, and they asked each of them, in effect, to place their bets, to say how likely it seemed that the wreck rested in this square, or that one, or the one just beside it. From all those careful guesses, they built something remarkable, a map not of the ocean itself, but of belief. A map where some squares glowed bright with high probability and others lay dim, and every single square held a number, a measure of how strongly they thought the lost submarine might be there. It was a portrait of their own uncertainty, drawn honestly and patiently, square by square by square. And then the real search began, guided entirely by that map. They looked first where belief was densest, where the numbers ran highest, and here is the quietly beautiful part. Each time they searched a promising square and found nothing, they did not simply cross it off and move along. They let that emptiness ripple outward across the whole map. Because if the wreck was not in the most likely place, then it became, by that very fact, a little more likely to be somewhere else. The bright squares dimmed as they were searched and emptied. The remaining squares brightened in answer. The map was alive, almost breathing, redrawing itself with every patch of barren seabed, always pointing with steadily growing confidence toward wherever the submarine had not yet been ruled out. Following that shifting map of belief, they found her. The Scorpion was located on the floor of the ocean, close to where all those gathered probabilities had come, in the end, to rest. The method did not retire with that one search. Decades later, in the summer of 2009, an airliner, Air France Flight 447, vanished over the Atlantic in a storm, carrying everyone aboard down into the deep. For 2 long years, searchers combed the water and came back empty-handed. The recorders stayed silent far below. And then a team returned to the same patient idea: gather everything known and unknown, draw a map of probability across the sea, and let it guide the way. They built their map. They went where it pointed most strongly, and in the spring of 2011, the wreckage was found at last, resting on the seabed close to where the map had quietly said to look. There's a strange and lasting comfort in this if you let it settle over you. We tend to think of uncertainty as a kind of fog, formless, shapeless, a simple absence of knowing. But the searchers discovered something gentler and truer. Even total uncertainty has a shape. It can be drawn. It can be weighed square by square and held in the hand like an ordinary map. And once you have admitted honestly and fully everything you do not know, once you have laid out your own ignorance plainly, without pretending it away, you have already taken the first real step toward finding what was lost. It is a tender thing to carry with you into the dark. That not knowing is not the enemy of finding, but the very ground that finding stands upon. That the way toward the truth often begins not with a confident leap, but with the humble, careful labor of mapping out exactly how lost you are, and then letting each empty place you search quietly light the path toward the next. So picture it now as you drift, the wide black water still and cold and deep, and above it, unseen, a soft grid of belief settling gently over the waves, dim here, bright there, patiently waiting to show the way down to whatever rests below. Hold a hollow mask up and look at it from behind, and your brain will swear that its empty face is bulging toward you. It is one of the strangest, gentlest tricks your mind will ever play on you, and you can feel it happen in real time. Take the inside of a mask, the concave side, scooped out like the inside of a spoon, curving away from you. Every honest signal reaching your eyes says hollow. The shadows fall the way shadows fall inside a bowl. The edges curve inward. And yet, almost helplessly, you see a normal face, a solid face, its nose and cheeks pushing gently out toward you. You can know with total certainty that the surface is hollow, and you will still see it bulge. The illusion simply will not let go of you. Why? Because in all your life, you have seen a great many faces, and every single one of them pushed outward. Faces are convex. They always have been. Your brain has met so many of them that it no longer treats this face curves outward as a guess at all. It treats it as something close to a law of the world. So when the strange hollow mask arrives, contradicting a lifetime of evidence, your brain quietly overrules your eyes. It decides, far beneath any thought, that a bulging face is so overwhelmingly more likely than a hollow one that the hollow reading simply cannot be right. And so it shows you the only kind of face it truly believes in. This is not your eyes failing you. It is very nearly the opposite. It is your eyes working exactly as they always do, leaning on everything you have ever seen to make sense of what sits before you now. Most of the time, that leaning is a quiet gift. It lets you recognize a friend's face in a dim room, or read a smudged and hurried word without effort, by filling in the likely answer faster than the raw light ever could. The illusion is simply one of the rare moments when the world hands your brain something so unusual that its confident expectation and the actual truth pull hard in opposite directions. And you get to watch, astonished, as the expectation wins. You have lived through other versions of this without ever realizing it. Perhaps you remember a certain photograph of a dress that swept across the world some years ago. A dress that looked plainly blue and black to some people, and just as plainly white and gold to others, with each side baffled that anyone could possibly see it the other way. There was a real answer about the dress itself, but the disagreement came from somewhere deeper. Each brain was quietly guessing at the light in the room where the photo was taken. Whether the dress stood in cool shadow or warm glow, and then stripping that imagined light back out to find the true color underneath. Those who assumed one kind of light saw one dress, those who assumed another saw another. The same handful of pixels, read through two different expectations, became two different garments. No one was truly wrong. Everyone was simply seeing their own best guess. There are quieter examples that work on almost everyone alive. Show the eye two small patches of gray. Arrange a soft shadow falling across a checkered surface just so, and two squares that are physically, measurably the identical shade of gray will look obviously, undeniably different. One bright, one dark. The reason is the same. Your brain sees the shadow, knows that shadow darkens whatever it falls upon, and silently corrects for it, brightening the square it believes is hidden in the shade. It is trying, faithfully, to show you the world as it really is, beneath the passing accidents of lighting. And in correcting so faithfully, it shows you something that is not, in plain fact, there at all. There is a humility in this worth holding on to. What you see is never the world, plain and unfiltered. It is always in part a story your brain is telling, its best, swift, usually invisible guess about what is most likely out there, stitched together from everything it has ever known before. The illusions are precious, not because they are failures, but because they are the rare cracks through which you can glimpse the storytelling itself. They are the few moments when the guess and the world disagree loudly enough that, just for once, you can catch your own mind in the gentle act of inventing what you see. So let your eyes soften now and let the images blur and slide. Soon they will close entirely, and the guessing will turn quietly inward with no world left to correct it. The very same machinery that paints your waking days, now left alone, at last, to dream. 3 doors stand before you. One hides a prize. You point at one, and the moment you do, the odds begin to move in a way that almost no one believes at first. Here is the game, and it is worth picturing slowly, because the puzzle inside it has fooled brilliant people for years. Before you are 3 closed doors. Behind one of them waits something wonderful. Behind the other 2, nothing at all. You do not know which is which. You simply choose. Let us say you rest your hand on the first door. It stays closed for now. Then the host steps in. And this host is no ordinary bystander. The host knows exactly where the prize is. With your hand still on door 1, the host walks over to one of the 2 doors you did not pick and opens it and reveals that it is empty. Now 2 doors remain closed. Your first door and one other. The prize is behind one of them, and the host turns to you with a choice. You may keep the door you first chose, or you may switch to the other closed one. What do you do? Almost everyone feels deep in their bones that it cannot possibly matter. 2 doors, 1 prize. Surely it is now a simple coin's flip, an even chance either way. To switch or to stay feels like the very same gamble wearing 2 different coats. But it is not. If you switch, you will win the prize 2 times out of every 3. If you stay, only 1 time in 3. Switching is twice as good, and the reason why is one of the loveliest small lessons in all of reasoning. Go back for a moment to the instant you first chose. At that point, with all 3 doors closed and nothing yet revealed, your chance of having pointed at the right one was 1 in 3. Plain and simple. Which means the chance that the prize was somewhere among the 2 doors you did not pick was 2 in 3. That is the key, and it never goes away. Together, those other 2 doors held twice the chance of hiding the prize that your single door did. Now watch what the host actually did. The host did not open a door at random and did not open your door. The host deliberately reached into that 2 out of 3 region, the doors you had passed over, and threw open the empty one. The host knew which to avoid. And so all of that 2 in 3 chance, which had been spread across both of those doors, did not simply vanish when one of them was opened. It slid whole and undivided onto the single closed door that remained on that side. Your door still carries the 1 in 3 it always had. The other door now carries the full 2 and 3. The host, by knowingly clearing away an empty door, quietly handed you that information and pointed without a single word toward the better choice. If it still feels slippery, here's a way to make it plain. Imagine the very same game, but with 100 doors instead of 3. You pick one, a single door out of 100, a 1 in 100 shot, almost certainly wrong. Then the host, who knows where the prize is, walks down the long row and opens 98 other doors, every one of them empty, carefully leaving shut only your door and one single other. Now look at those 2 remaining doors. Do you truly believe it is an even chance between them? Or do you feel, suddenly and clearly, that the prize is almost surely behind that other door, the one the host went out of their way to leave standing, while your first lonely guess was very probably wrong all along? With 100 doors, the truth fairly leaps out at you. With only 3, the very same thing is happening, just quietly enough to stay hidden. And here is the gentle wonder underneath the whole trick. New information is not simply a fact added to a pile. It reaches back and reshapes the chances of everything it touches. The opening of one empty door changed nothing you could see about the door beneath your hand, and yet it transformed what that door was worth and what the other door was worth, all at once. Knowledge does not merely gather and stack. It flows and it redistributes, and it quietly rewrites the odds of the world around you. So let the 3 doors stand there in the soft dark, 2 of them still closed, one drifting open onto its emptiness. There is no need to choose anything tonight, only to notice as you fade how a single small revelation can ripple outward and change the shape of everything around it. Ask 2 mathematicians a simple question: what is a probability? And you may quietly begin an argument that has already lasted more than 100 years. The question sounds almost too easy to bother with. We say such things all the time. A 70% chance of rain, a coin that comes up heads half the time, 1 chance in a million. The words feel solid, obvious, the kind of thing everyone surely agrees about. And yet beneath them lies a genuine, unresolved disagreement about what those numbers actually mean. A soft fault line that runs through the whole of mathematics, and along which thoughtful people have settled into 2 great camps. Stand for a moment with the first camp. To them, a probability is a frequency, a fact about how often something happens when the world is allowed to repeat. Say a coin has a 1/2 chance of landing heads, and they will tell you precisely what that means. Flip it 10 times, 100 times, 1,000 times, and the share of heads will settle closer and closer to 1/2. The probability lives out there in the long run of repetition, in the patient tally of trials. It is a property of the coin and the flipping, as real and as external as the coin's own weight. And to this way of seeing, it only makes clean sense to speak of probability when you can imagine that repetition, a thing that could happen again and again, so that the frequency has room to reveal itself. Now turn and stand instead with the second camp, and the whole picture quietly shifts beneath you. To them, a probability is not out in the world at all. It is in the mind. It is a measure of belief, of how confident you are given what you happen to know. A probability of 1/2 is not a promise about 1,000 future flips. It is simply a statement that with the evidence you hold right now, you see heads and tails as equally believable for this one flip about to happen. And because it lives in your knowledge rather than in the world's repetitions, you are suddenly free to speak of the probability of things that will only ever happen once. The chance that a particular person is ill tonight, the chance that some long-buried event truly occurred, the chance of a single election, a single storm, a single irreplaceable moment that will never come again. There is no long run for any of these. They happen once or not at all, and yet to this camp it is perfectly sensible to give them a number, because the number was never about repetition. It was always about how much you believe. Neither camp is foolish. That is the part most worth sitting with. These are not the careless and the careful, the wrong and the right. They are two honest answers to a question that turns out to be far deeper than it first appeared. Where does chance actually live? One camp anchors it firmly to the world, to coins and dice and the long, repeatable churn of events where probability can be checked by simply counting. The other anchors it to the knower, to the state of a mind facing an uncertain world, where probability measures the very texture of what you do and do not yet understand. The first asks, how often? The second asks, how sure? And a great deal of how we reason and argue and decide depends quietly on which of those two questions we believe we are answering. You meet this split far more often than you know, though it almost never announces itself. When a forecaster says there is a 30% chance of rain tomorrow, what can that possibly mean? Tomorrow will happen only once. It will either rain or it will not. One camp hears it as a frequency drawn from many similar days in the past that resembled this one. On days like tomorrow, it rained about 3 times in 10. The other hears it as a confidence. The forecaster's honest degree of belief, given the maps and the winds and the patterns they have learned to read. Two listeners, the very same words, two different things heard, and both within their own frame, entirely sensible. There's a gentle humility in noticing this. Numbers feel like the most solid things we have, clean, certain, beyond all argument. And yet even a simple probability rests quietly on a choice about what we mean by it. The figure on the page does not tell you all by itself whether it is counting the world's repetitions or measuring a single mind's belief. It waits patiently for you to decide what kind of thing it is. So let the question rest unanswered tonight, the way the very best questions do. Picture two figures seated on either side of a single fire, one watching the flames flicker and quietly counting, one gazing into them and softly wondering. Both looking at the very same light and seeing it differently, and both in the warm and easy dark, entirely at peace. There is no law of logic that forces the sun to rise tomorrow. It sounds almost foolish to say it. Of course it will rise. It has risen on every single morning of your life, and every morning of your parents' lives, and every morning stretching back through all of human memory, billions upon billions of dawns, never once skipped, never once forgotten. And yet here's the quiet, unsettling truth that careful thinkers have wrestled with for centuries. None of that, strictly speaking, proves it must rise again. Walk through the reasoning slowly because it is gentler and stranger than it first appears. Why do you believe the sun will rise tomorrow? Because it always has. But notice what that simple argument quietly assumes, that the future will go on resembling the past. And how do you know the future will resemble the past? Only because, so far, it always has. The days to come have, until now, kept on looking like the days that came before. But that is the very thing you were trying to prove, slipped back in again as your reason for believing it. The argument bends around and quietly bites its own tail. Logic alone, it turns out, cannot carry you across the small dark gap between everything always has and therefore it surely will. A philosopher named David Hume laid this bare more than 2 centuries ago, and it has troubled thoughtful minds ever since. We lean our whole lives on the expectation that tomorrow will behave like today, that bread will still nourish us, that fire will still warm us, that the ground will still hold firm beneath our feet. We have no choice but to. And every bit of it rests at the very bottom, not on airtight proof, but on a kind of deep and unspoken trust in the steadiness of the world. But where Hume saw a puzzle, a great mathematician saw a question he could actually begin to answer. His name was Pierre-Simon Laplace, and he asked something delightfully precise. Suppose you knew nothing at all about the sun, nothing of fire or physics or turning worlds, and all you had to go on was the bare tally of mornings. The sun has risen, let us say, on every one of the days you have ever counted. Given only that long, unbroken streak and nothing more, how confident should you be that it rises once again? Laplace found a way to put an actual number on it. With each new dawn that arrives faithfully on schedule, your confidence ought to climb, higher and higher, creeping ever closer to certainty. It works rather like guessing at a hidden coin by watching it land. A long, long run of the same result gradually convinces you the coin is heavily weighted that way. And after the thousands of years that human beings have kept watch on the sky, hundreds of thousands of dawns recorded without a single failure, the number Laplace arrives at sits just a hair's breadth below perfect certainty, astonishingly close to 1, but never quite exactly 1. There remains, always, an unimaginably thin sliver of doubt, a sliver that the longest streak in the world can shrink almost to nothing and yet never fully close. And Laplace, to his lasting credit, was honest about the limits of his own little calculation. He noted plainly that this bare counting of dawns is only the answer for someone who knows nothing else. Someone with no understanding of the great machinery beneath the sky. Anyone who grasps the turning of the earth, the steadiness of the sun, the deep and patient laws that hold the heavens in their courses, may stand on far firmer ground than mere counting allows. They are not simply tallying mornings. They are seeing the mechanism that makes the mornings happen at all. And that is a sturdier and richer kind of knowing. Still, something in that lingering sliver of doubt is worth holding close as you drift towards sleep. It whispers that even our surest knowledge, the things we would never dream of questioning, rests in the end not on ironclad proof, but on a kind of earned and patient trust. A trust built up morning by morning, dawn after faithful dawn, until it grew so solid and so seamless that we long ago forgot it had ever been trust at all. There is no anxiety in this, only a quiet wonder. The sun will almost certainly rise tomorrow. The earth will keep its ancient turning, as it has for billions of years, and the light will come spilling over the curved edge of the world just as it always does. That thinnest thread of mystery does nothing to threaten the promise. It only reminds us how much of our settled, certain life is woven from a trust so deep and so well kept that it has come to feel exactly like certainty itself. So rest now in the soft dark before the dawn. The world is turning quietly the way it always has, and somewhere far beyond the horizon, the light is already on its way, almost certain, almost promised, gathering at the edge of the night to spill once more gently into morning. by the simple fact of being born when you were. Some thinkers say, you can make a guess about how long humanity has left. It is one of the strangest arguments ever taken seriously, and I want to share it gently because it is far more a curious puzzle than any kind of prophecy. Begin with a number that is itself quietly staggering. Somewhere around 100 billion human beings have ever lived. Every person who has walked the earth, from the very first of our kind to you lying here tonight. 100 billion lives, lit and then dimmed, stretching back across the long dark of time. And you are, very roughly, somewhere near the 100 billionth of them. Now imagine all the humans who will ever live, every person past, present, and yet to come, lined up in one immense row, in the order they were born. The first human at the front, the last human, whoever they turn out to be, at the very end. You stand somewhere in that line, but you do not know where. You cannot see the front from where you are, and you certainly cannot see the end. Here's the move that makes the whole argument turn. Suppose you assume you are nothing special, that your place in the line is just an ordinary one, no more likely to be freakishly near the beginning than anywhere else. If that is so, then you are probably somewhere in the broad middle of the line, rather than perched improbably at its very dawn. And if you really are roughly in the middle, then the number of humans still to come after you cannot be vastly, astronomically larger than the 100 billion who came before. The line, in other words, may not run on for nearly as long as we like to imagine. There's a simpler way to feel the shape of it. Picture a great jar filled with numbered tickets, and you have no idea how many tickets it holds. It might be hundreds, it might be billions. You reach in and draw one out, and it reads number 100. What does that tell you? If the jar held 1 trillion tickets, it would be a wild stroke of luck to have drawn such a low number on your very first try. Far more likely, the jar is modest, holding perhaps a few hundred tickets, not countless billions. Your low number is a quiet piece of evidence that the jar is small. And the argument simply treats your place in the human line as one such ticket, drawn at random from all of history. A scientist named Gott once played with this same reasoning in a wonderfully bold way. Standing before the Berlin Wall many years ago, he reasoned that since he was seeing it at no special moment in its life, he could estimate roughly how much longer it would stand. And his rough prediction, made years ahead of time, held up remarkably well when the wall finally came down. He later used the very same trick to guess how long a whole list of theater plays would keep running, and again his estimates landed surprisingly close. And now the most important thing of all, the thing to hold on to as you listen. This is one of the most fiercely debated arguments in all of philosophy, and it is very far from settled. It rests entirely on a single slippery assumption, that you may treat yourself as a random sample, drawn from all the humans who will ever live. And a great many brilliant people believe that assumption is simply mistaken, or even quietly meaningless. It is a provocation, a thought experiment that pokes at the edges of how we reason about ourselves and our place in time. It is not a forecast, and it is most certainly not anything to lose a moment's sleep over. What lingers when the unease drains away is not the conclusion, but the sheer audacity of the thing. That a single number, your place in a line you never chose to join, could even seem to whisper something about the fate of everything that comes after. Whether the argument holds or crumbles, it does something tender along the way. It makes you feel, suddenly and vividly, how fine a thread connects your one small life to the whole vast sweep of human time. All those who came before, all those who may yet come. So let the worry of it go entirely and keep only the wonder. Picture that long, long line of humanity stretching back into the dark, 100 billion souls, each one a small flame that flickered for a while and then was gently passed onward. And there, somewhere in the warm middle of all of them, one quiet light among countless others, is you, held for this moment in the company of everyone who has ever been. The quiet guardian that sorts the junk from your mail was never handed a single rule about what junk looks like. No person ever sat down and wrote out the instructions for it. No list that said, if a message mentions a prize, mark it as junk. If it shouts about a fortune, throw it away. That is not how it came to know the difference at all. Instead, the filter taught itself in the gentlest and most patient way imaginable. It learned by reading. Picture how it grew up. It was shown thousands upon thousands of messages that people had already sorted by hand. This great pile marked as unwanted junk, this other great pile marked as mail worth keeping. And the filter did something almost childishly simple with them. It counted words. It noticed which words turned up again and again in the junk pile. Words about lottery winnings, urgent riches, miracle cures, desperate pleas for just a little money. And it noticed which words lived mostly in the good pile. A colleague's name, the project you were working on, the ordinary warm language of people who actually know you. Each word, by how often it appeared on one side or the other, became a tiny piece of evidence. A small lean, this way or that. A faint whisper of junk, or a faint whisper of welcome. Then, when a brand new message arrives, the filter does not judge it all at once, as a single thing. It reads it the way you might read a stranger's face, feature by feature. Each word nudges a running estimate, ever so slightly, up or down. This word makes junk a little more likely. That word makes it a little less. A dozen small nudges, 100 small nudges, each one gentle on its own, and the filter gathers them all together into a single quiet verdict. Keep this one, set that one aside, and the loveliest cases are the close ones, where the evidence pulls hard in both directions at once. A message might open with the warm, familiar name of someone you trust, and the estimate leans gently toward welcome. And then a line or two later, it promises a sudden fortune in exchange for one small favor, and the estimate swings quietly back the other way. You can almost picture a little scale tipping and tipping as the filter reads, first one direction and then the other, settling and unsettling, until the very last word has been weighed and it finally comes to rest. No single word ever decides it alone. The verdict simply emerges from the whole, from the patient gathering of every small lean. There is a charming simplification hidden in how it works, and it is worth knowing. The filter pretends, for the sake of ease, that each word speaks entirely on its own, as if no word ever leaned on the words around it. That is not quite true to how language really behaves. Words travel in clusters, they color one another. A single word can mean two different things in two different sentences. The filter cheerfully ignores all of that. And the wonderful, slightly absurd thing is that this not quite right shortcut works astonishingly well anyway. A small, knowing lie about how language behaves, somehow giving very honest answers, and it never stops learning. Every time you reach into the junk folder and pull something out, Rescuing a message that should never have been buried, you are teaching it. Every time you take an unwanted thing and send it away, you are teaching it. Quietly, in the background, its sense of which words mean welcome and which mean trouble grows a little sharper with each correction, shaped by you, day after day, the way a path through grass is worn slowly smoother by footsteps. There is something quietly moving in all of this, if you let yourself feel it. A machine can come to know something not because it was told, but because it was shown, patiently, repeatedly, example after example, until the pattern settled in. It is not so very different, when you think about it, from the way a small child learns which words are kind and which are sharp. No one hands a child a rule book of language. The child simply listens, over and over, in the rooms where the words are spoken, and slowly the meanings take hold. And this humble little word counter, this quiet sorter of mail, turns out to be a kind of ancestor. The simple, profound idea at its heart, that a machine might learn from a great heap of examples rather than from rules written by hand, became one of the seeds from which much grander forms of machine learning later grew. The thing keeping your inbox tidy tonight is a distant, gentle cousin of far larger minds. So picture it now as you let the day's clutter fall away, your inbox resting in the dark, and somewhere inside it, a small and tireless attention, quietly reading every word as it arrives, weighing each one with the soft wisdom it gathered from all the messages that came before, sorting, learning, keeping watch over the little gate so that you do not have to while you sleep. The moment you become completely certain of something, you can never again learn that you were wrong. It is a strange thing to say aloud, and stranger still to find that it is, in a precise sense, simply true. Absolute certainty is a kind of locked door. If you are 100% sure of something, not very sure, not nearly sure, but perfectly and completely sure, then no fact, no proof, no flood of contrary evidence pouring in from the world can ever move you. Your mind has nowhere left to go. And the surprising part is that this is not merely a fact about stubborn people. It falls right out of the quiet mathematics of how a belief is meant to change. Let me show you the shape of it, gently, without a single number. Imagine that a belief is something the world keeps multiplying. Each new piece of evidence arrives and quietly multiplies your confidence, lifting it upward when the evidence supports you, pressing it downward when the evidence pushes back. That is the whole rhythm of learning. Belief met by evidence, gently scaled up or down, again and again, as the world reveals itself. Now think about what happens at the very edges. A belief held at absolute zero, total perfect disbelief, the conviction that something is flatly impossible, is like a number multiplied endlessly by zero. No matter how much supporting evidence the world piles on afterward, anything multiplied by zero stays stubbornly at zero. The door will not open. And a belief held at perfect absolute one is caught in the very same trap from the other side, frozen, immovable, deaf to anything the world might try to say. Only a belief held with the faintest give in it, even the thinnest sliver less than total certainty, leaves the smallest crack for the world to reach through and move you. This humble, powerful idea carries a strange and very human name. Long ago, a man named Oliver Cromwell wrote to a group of churchmen who were utterly, immovably convinced that they alone were right about a grave matter. And he pleaded with them, in words that have echoed down the centuries since. "Think it possible," he wrote, that you may be mistaken. Much later, a thoughtful statistician was so struck by the wisdom buried in that plea that he gave its name to this whole principle. The rule that you should never, ever hold a belief at a flat and final 0 or 1, lest you wall yourself off from the truth forever. So the rule is, in the end, a piece of old human wisdom wearing the clothes of mathematics. Keep a sliver of doubt always. Not because you are weak or unsure of yourself or unwilling to commit, but because that sliver is the one small thing that keeps your mind alive and open to whatever the world has yet to show you. Certainty can feel like strength, solid and reassuring, but pressed all the way to its absolute limit, it becomes instead a kind of quiet deafness, a sealing off, a refusal that wears the mask of confidence. You have surely met this in a quiet way somewhere in your life. Think of someone so completely sure of a thing, about another person, about how the world works, about themselves, that no gentle word, no patient showing, no plain fact laid carefully before them could ever shift it by even a hair. The evidence arrives, and it simply slides off and away, finding nothing at all to hold to. It is not quite that such a person refuses to listen. It is that, having closed the very last small gap of doubt, they have left nothing for the listening to do. The door was shut so firmly and so long ago that the soft knocking at it can no longer be heard. There's a gentleness in this that is easy to miss. Humility, it turns out, is not the opposite of knowing. It is the very thing that lets know he growing. To hold even your deepest, dearest belief with just a feather's weight of openness, to leave room, however small, for the thought that you might have it wrong, is to remain, for your whole life long, a person who can still be surprised by the truth. A person the world can still reach. A person who is still, in the truest sense, learning. And there's something restful in that once you stop fighting it. You do not have to be certain of everything tonight. You do not have to have it all nailed down, sealed shut, finally and forever resolved. You are allowed to hold your beliefs lightly, kindly, with a little air around them, to let them breathe and shift and grow as gently as you yourself are breathing now. So picture, as you drift off, a single door at the end of a quiet hall, not flung wide and not slammed shut, but left just barely ajar, a thin, soft line of light glowing along its edge, never fully closed, always, however slightly, able to open. There is a way of reading the deepest equation in all of physics that says it is not about the universe at all. It is about you. To feel the strangeness of this, you first have to meet a peculiar object that sits at the very heart of quantum physics, the science of the tiniest things, the atoms and particles from which everything is built. That object is called the wave function, and physicists use it to predict with breathtaking accuracy how those tiny things will behave. The trouble is that for an entire century, the cleverest minds alive have argued bitterly about what the wave function actually is. Is it a real thing, spread out in space like a ripple moving across the surface of a pond? Or is it something far stranger, something that isn't quite out there in the world at all? One bold and beautiful answer says this: the wave function is not a thing in the world. It is a catalog of your own beliefs. It is a precise, careful summary of what you, the one doing the looking, expect to find when you next reach out and interact with the world. It lives not in space, but in the mind of the observer, the way a hunch or an expectation lives in yours. And then comes the famous, eerie moment that has haunted quantum physics from the beginning, the the so-called collapse. Before you look, a tiny particle seems to hover in a haze of many possibilities at once, here and there and everywhere, undecided. And then you measure it, and in an instant, the haze vanishes and the particle is simply somewhere, definite and singular. For 100 years, this has seemed to demand that something physical, something real, dramatically snaps into place the very moment we peak. But in this gentler reading, nothing collapses anywhere at all. There is no physical snapping. There is only you updating, quietly revising your expectations the instant the world hands you a new answer, in exactly the same ordinary way that anyone changes their mind upon learning something they did not know before. Think for a moment of a letter sealed inside an envelope, carrying news you have been waiting on for a long while. Before you open it, the news could be almost anything, joyful or sorrowful, every possibility alive and unsettled at once in your mind. Then you break the seal and read it, and in that instant, the whole cloud of maybes simply vanishes, and there is only the single true answer playing on the page. Yet nothing in the world rearranged itself when you opened it. The words had already been written days ago by another hand. What changed was you, what you now knew, and so what you now believed. This gentle reading of quantum physics says the famous collapse is no stranger than that opening letter. Not the universe reshaping itself the moment you glance, but a knower, quietly coming to know. So the probabilities woven through quantum mechanics in this view are not stitched into the fabric of reality itself. They live in the observer. They measure your personal uncertainty about what you are about to see, which brings the very strangest physics we have ever discovered surprisingly, almost shockingly, close to the plain and homely act of changing one's mind. Now I must be careful and honest with you, because this matters. What I have described is one interpretation among several, and it is deeply, genuinely contested. Other thinkers read the same physics in completely different ways, some insisting the wave function is utterly real, some imagining the world splitting endlessly into countless branches. The equations themselves, and their astonishingly accurate predictions, are not in dispute. Every physicist agrees on those, and they have been confirmed to staggering precision. It is only the meaning underneath that remains wide open. No experiment has ever settled which reading is right. Some physicists find this particular view liberating and clean. Others find it troubling, because it seems to place the observer rather than the world at the very center of the story. But whether it turns out to be right or wrong, simply holding the thought is a quietly staggering thing. It raises the possibility that the line between the grand physics of the cosmos and the soft private workings of a believing mind might be far blurrier than we ever dared to imagine. That a statement about the state of the universe, written out in cold mathematical symbols, might secretly be a statement about someone's expectations. That the knower and the known might be tangled together far more intimately than they appear. It stirs a strange humility and a strange intimacy, both at once. The possibility that you are not a distant spectator, watching reality unfold from somewhere safely outside it, but a participant, woven right into the weave, your every glance and every measurement, a small act of updating, in a universe that may not quite finish making up its mind until someone, somewhere looks. So let one last image settle over you as you drift. A single tiny particle, far smaller than sight, resting in its soft haze of maybes in the dark. Not a hard little thing sitting out there waiting to be caught, but something more like a question, gently held, patient and unhurried, suspended in possibility until you turn your quiet gaze toward it, and it answers. From a few numbers stamped on the sides of captured tanks, a small group of mathematicians counted an enemy's entire secret army and got the answer very nearly right. It happened during the Great War of the last century, when one side desperately needed to know how many tanks the other was building, month after month, in factories hidden far beyond their reach. Spies tried to find out, and guessed. Reconnaissance planes flew over and photographed what they could, and guessed. And a quiet handful of statisticians, working with pencil and paper far from any battlefield, did something altogether different and far more accurate. They simply read the serial numbers. Here is the lovely, almost obvious idea once you see it. Every tank rolling off a production line carried a serial number stamped into it in plain sequence. 1, then 2, then 3, and onward. Each new machine numbered just after the last. And whenever one of those tanks was captured or knocked out and examined, that number could be quietly recorded. A serial number, you see, is a wonderfully honest little informant. It cannot help telling the truth about its own place in the order. It does not exaggerate, and it does not lie. Let me give you the feel of how the reasoning works, because it is the kind of thing you can almost do in your head. Suppose you have captured just a handful of tanks, say 5 of them, and the highest serial number among all 5 is 60. Now ask yourself gently what that single fact implies. If the enemy had truly built thousands upon thousands of tanks, then it would be a remarkable stroke of luck to have caught 5 of them, all bearing such low numbers, all huddled down near the very start of the sequence. Far more likely, the total is not much greater than 60. The line is short, and the spacing of the numbers helps too. If your captured 5 are bunched tightly together down at the low end, the whole run is probably small. If they are scattered far and wide, it likely runs much longer. From a small fistful of stamped digits, a simple and elegant piece of mathematics reaches out and estimates the size of the entire hidden whole. And then comes the part that still makes statisticians smile. All these years later, when the serial number method was set side by side with the work of the spies and the aerial photographs, the two answers could scarcely have been further apart. Where the cloak and dagger estimates put the enemy's production at well over 1,000 tanks every month, the quiet mathematics put it at only a few hundred. One answer was loud and alarming. The other was modest and almost dull. They simply could not both be right. And when the long war at last came to its end, and the captured factory records were finally pried open and laid bare, the truth came out plainly for all to see. The statisticians, with nothing but their stamped numbers and their careful sums, had been astonishingly close to the real figure. And the dramatic estimates of the spies, the frightening numbers, the ones that had seemed so urgent and so credible, had been wildly, badly, almost embarrassingly wrong, and the method did not retire when the war finally did. That same quiet idea that the largest serial number you have glimpsed, taken together with how your scattered glimpses are spread across the whole run, can reveal the size of a thing you can never see directly, still serves us softly today, in fields far from any battlefield. Wherever someone must judge a hidden total from nothing but a small scattered handful of samples, Some faint echo of this reasoning is often quietly at work. The trick those statisticians sharpened against an enemy's hidden factories turned out to be a small and lasting gift to the simple, ancient art of estimating the unseen. There is something quietly humbling in that, and quietly thrilling too. That a few small, overlooked details, gathered and read with patience and care, can outperform all the daring and intrigue of espionage. That the world is forever leaving honest little clues lying about. Clues to its hidden size, its secret shape, the scale of things we cannot see directly. And that the clues are often hiding in the dullest, most ordinary places, in numbers no one thought to truly listen to. The truth, it seems, has a way of leaking out through the smallest of cracks, if only someone knows how to read it. So let that gentle thought carry you down towards sleep. Picture a short row of serial numbers in the soft half-light, small and plain and patient, each one a tiny, truthful whisper, each one quietly giving away a piece of a vastness no eye could ever have seen. A few humble marks, holding the secret of an entire hidden world, waiting only for someone calm enough and curious enough to listen. Inside every living thing is a hidden record of who its ancestors were, written letter by letter in the long, coiled script of its DNA. It is one of the quietest wonders in all of nature. The cells of your body carry a vast text spelled out in a tiny alphabet, copied faithfully from your parents and from their parents, and back through an unbroken line stretching into the deep past. And the astonishing thing is that the very same kind of text, written in the very same alphabet, runs through every creature that has ever lived. The grass outside, the bird in the tree, the mushroom in the dark soil, the unseen bacteria drifting in a drop of water. All of them carry a version of the same ancient script, altered here and there over unfathomable stretches of time. And because life passes its text down by copying it, with only the smallest of changes creeping in along the way, the pattern of those changes becomes a kind of family record. Creatures that share a recent ancestor share most of their text, like cousins who grew up in the same house. Creatures whose paths split long ago share far less. So hidden in the differences and the likenesses, written in chemistry, is a genealogy of all living things, a record of who descended from whom and when their roads diverged. The trouble is the sheer vastness of the puzzle. Suppose you wanted to work out the true family tree connecting even a modest handful of species. The number of possible trees you could draw, all the different ways they might branch and connect, grows staggeringly fast. For even a few dozen creatures, the possible trees outnumber the atoms in the observable universe. No one could ever sit down and check them all, one by one, not in 1,000 lifetimes, not in the whole age of the cosmos, so we do not check them all. Instead, a beautiful method goes wandering through that endless forest of possible trees, and it is drawn always toward the trees that best explain the actual DNA we can read in living things today. It lingers longest among the trees that fit the evidence well, and drifts quickly away from the ones that fit it poorly. It wanders and weighs and wanders again, and from all that patient roaming, it returns the family trees that are most probable, and tells us, branch by branch, how confident we are allowed to be in each one. It does not pretend to perfect certainty. It hands us the most believable shape of the past, along with an honest measure of our own doubt. And what this patient reading reveals is sometimes wonderfully surprising. Creatures that look almost nothing alike can turn out to be close cousins, their kinship hidden entirely beneath wildly different shapes and ways of living. And others that seem to the eye like obvious relatives can prove to be near strangers, two distant branches that merely happened over long stretches of time to grow into similar forms for similar reasons. The DNA does not care in the slightest what a creature looks like on the outside. It quietly tells the deeper truth of who is truly related to whom and how long ago their separate paths first parted. This is how the great tree of life has been drawn, the sprawling, branching diagram that connects every living thing back to shared beginnings. It is how we have come to know, not as a poem but as a physical fact, that you and the redwood on the hillside are distant kin, that you and the whale in the deep ocean trace back, if you follow the branches down far enough, to a common ancestor. That every leaf on that immense tree, every creature that has ever drawn breath or photosynthesized light or simply divided in two, is bound to every other by a thread of inheritance that has never once been broken since life began. There is something that catches in the chest about that, if you let it settle. The proof of your kinship with all living things is not a lovely idea someone dreamed up. It is written right now in the cells of your own body, readable, testable, undeniable. You are quite literally related to the moss and the moth and the ancient bacterium, and the evidence is folded into every cell you carry, waiting only to be read. So let one last image carry you down towards sleep. Picture a single vast tree standing in the soft dark, its trunk lost in the deep past, its countless branches spreading upward and outward, and on every farthest twig a single living thing. The grass and the whales and the mushrooms and you, all of you out at the bright green edges, all of you stirred by the same sap rising from one ancient and patient root. One tree, one family, and you, a small leaf among uncountable others, breathing quietly in the same old wind that moves through all of them. A spacecraft falling through the dark between worlds never quite knows exactly where it is. It is a strange thing to sit with. We picture these machines as marvels of precision, and they are. Yet out in the vastness, a craft can never simply read its own position the way you read the time on a clock. Its instruments are noisy, jittering with tiny errors. The distances are unimaginable. Every measurement it takes is a little uncertain, a little smudged, and still, somehow, it finds its way across hundreds of thousands of miles of emptiness and arrives, gently, exactly where it meant to go. It manages this not by trusting any single reading completely, but by doing something humbler and far wiser. Guessing, checking, and refining, over and over, without end. Let me show you the quiet loop at the heart of it, because it is simpler and lovelier than you might think. The craft does just two things, again and again. First, it predicts, based on how it was just moving a moment ago, its speed, its direction, the gentle pull of gravity upon it. It makes a confident guess about where it ought to be now. A coasting estimate drawn purely from its own expectations. Then second, it listens. A sensor speaks up with a fresh measurement of where it actually seems to be, and that reading too is noisy and imperfect, never wholly to be trusted. Now here is the heart of the thing, the small piece of grace. The craft trusts neither one completely. It does not throw away its careful prediction and surrender blindly to the sensor, and it does not cling stubbornly to its prediction and wave the new reading away. Instead, it gently blends the two together, leaning a little harder on whichever one it has more reason to trust in that moment. When the sensor is shaky and unreliable, it leans on its own steady prediction. When the sensor is sharp and clear, it leans toward the fresh reading. The blend of the two becomes its new best estimate of where it truly is. And then, a heartbeat later, it begins the whole gentle dance again. Predict, listen, blend, predict, listen, blend, forever. You do something quietly like this yourself, more often than you know. Picture moving through a darkened house you know well in the middle of the night. You do not stop, helpless in the black hallway. You predict. The doorway should be about here, the edge of the table just there. A few more steps until the stairs, moving on the strength of your own inner map of the place. And now and then a fingertip brushes the cool wall, or a shin finds the chair a little sooner than you expected, and you quietly correct, folding that small touch of evidence into your sense of where you are, and you walk on. Predicting, then checking, then gently blending the two. The very same dance the spacecraft does, performed in your own hallway, in your own dark. This patient loop is no abstract curiosity, a method very much like it rode aboard the first ships that carried human beings to the moon, helping their small onboard computers hold their bearings across the great gulf of space, blending what the craft expected with what its instruments reported, moment by moment, all the long way there and back. It was trusted with lives in the deepest dark there is. And the same quiet idea lives, even now, in your pocket. That small glowing dot on the map on your phone, the one that knows where you are as you walk down a street, that follows you faithfully around a corner, steadies itself in just this way. It blends a prediction of where you should be, based on how you are moving, with the noisy, uncertain readings trickling in from satellites far overhead, and it smooths all that jitter into a single calm and confident point. The very same dance that guided travelers to the moon now keeps you from getting lost on your way home. There's a strange wisdom buried in that loop, almost a way of living. It suggests that the path to finding your bearings in an uncertain world is not to seize on any one piece of information as the whole and final truth, and not to trust only your own expectations either. It is to hold the two together gently, what you expect and what the world is actually showing you, and to let each one quietly correct the other, again and again, patiently, until the way ahead grows clear. So let this be the image that carries you down, a small craft, drifting through the silent dark, making its tiny, ceaseless adjustments, never certain, always correcting, always drawing nearer to home. And the soft blue dot, resting steady on the map, quietly sure of where it is, finding its way as you let go and find yours into sleep. A woman agrees to be put to sleep and woken either once or twice depending on the flip of a single coin, and the simple question they ask her has no agreed answer to this day. Let me lay the little experiment out gently, because its strangeness only blooms once you see exactly how it works. A volunteer agrees to take part. On the first evening, she is put softly to sleep. While she sleeps, a fair coin is tossed. An ordinary coin, an honest 1 in 2 chance of landing either way. And what happens next depends entirely on how it falls. If the coin comes up heads, she will be woken only once the next morning. She will be asked a single question, and then the experiment will quietly end. But if the coin comes up tails, she will be woken twice, once on the first morning and again on the second. And here's the gentle twist that makes the whole thing turn. Between those two wakings, she is given something that softly erases her memory of the first. So when she wakes the second time, it feels exactly like the only time. She cannot tell on any given waking whether it is her first or her second, whether it is the morning after heads or one of the 2 mornings after tails. Each awakening feels identical, fresh, alone. And every single time she wakes, knowing all of this in advance, she is asked just one quiet question. How sure are you that the coin came up heads? One group of thoughtful people answers without hesitation. One has. The coin was perfectly fair, they say. She always knew, going in, that she would be woken and asked. So opening her eyes tells her nothing she did not already know. And with no new information, the chance of heads remains exactly what it always was, a simple 1 in 2. Another group answers just as confidently, 1/3. Think of all the wakings, they say. A heads gives a single waking. A tails gives 2. So there are 3 possible awakenings in all, each one equally likely to be the one she is living through right now, and only one of those 3 belongs to a world where the coin came up heads. So from inside the experience of waking, with no way to tell which morning this is, the chance of heads is 1 in 3. And the deep and delicious trouble is this: both arguments feel airtight. Read either one slowly and it seems plainly, obviously correct, until you read the other. Thoughtful people have turned this gentle puzzle over for decades now, and there is still no settled answer, no quiet agreement about who is right. It is not that the arithmetic is difficult. A child could follow either path. It is that the question hides a far deeper one inside it. What does it even mean to ask how likely something is when your uncertainty is not about the world out there, but about where you yourself are within it? When you might be living through one of 2 identical moments and cannot tell, even in principle, which. This is not merely a clever entertainment either. The very same strange confusion arises whenever a situation might repeat an observer, or copy them, or set them down somewhere they cannot quite locate themselves within the unfolding story. The riddle of the sleeping woman is simply the cleanest little room in which to meet that confusion. A quiet laboratory for a question that reaches much further than 1 coin and 1 bed. How are you meant to reason about your chances when part of what you are unsure of is not how the world turned out, but which version of this moment, among several identical ones, is the one you happen to be living through right now? Ordinary reasoning about chance quietly assumes you already know where you stand and asks only what the world will do next. Here, unsettlingly, it is your own place in things that has gone soft and uncertain. There is something tender and quietly dizzying in that. We lean on our sense of being somewhere definite, someone definite, living through this particular moment and no other. And this soft little riddle shows how that footing can slip, how simply not knowing which moment you are in can unsettle even the most basic certainty, can make the plain question how likely come apart gently in your hands. So let it rest there, unanswered, the way the loveliest questions do. Picture her drifting in and out of those identical dawns, never quite sure which one she is living, the fair coin resting somewhere unseen with its answer already given, and the soft question hanging in the still air, patient and unhurried, waiting for an answer that may never come, as she sleeps, and as you do too. Nudge a handful of the universe's most basic numbers by the slightest amount, and stars, planets, and life all become impossible. It is a sobering thing to learn. The whole vast cosmos runs on a small set of fundamental quantities. How strongly its forces pull and push, how much its empty space strains to expand, how heavy its smallest particles are. And several of these numbers appear to sit within strikingly narrow windows. Tilt one a little, and matter never gathers itself into stars at all. Tilt another, and the stars that do form burn out far too quickly for anything living to arise around them. Tilt a third, and atoms never settle into the rich, patient chemistry that bodies and brains are built from. Across more than one of these dials, the setting that allows a universe like ours, warm, structured, alive, seems to be perched on a surprisingly thin ledge. To get a feel for how delicate this can be, imagine balancing a pencil perfectly upright on its sharpened point and having it simply stay there, unwavering, hour after hour. Some of these cosmic quantities appear poised with a care a little like that, balanced so finely that the smallest nudge in either direction would topple the whole quiet possibility of a living universe before it ever had the chance to begin. And so a puzzle arises, one that has unsettled physicists for generations. Of all the values these numbers might have taken, why these? Why ones that happen to permit galaxies and starlight and the slow flowering of life? It can feel, when you first sit with it, almost as though the universe were set up with us in mind, tuned, like an instrument, to a key in which living things could one day sing. That unsettling feeling has a name. Scientists call it the fine-tuning of the universe, and it is a genuine and serious puzzle, not a fancy. One way of thinking gently turns the whole question around. Ask yourself this: in what kind of universe could a creature ever arise and look around and notice the numbers and wonder at them? Only in a universe whose numbers happen to allow such creatures to exist in the first place. A barren, hostile cosmos, one whose dials were set to forbid stars and chemistry and life, would have no one inside it to remark on how barren it was. There would be no astronomers in an empty universe. So perhaps we should not be quite so astonished to find ourselves in a life-friendly one. We could never have found ourselves anywhere else. Our very presence, doing the wondering, quietly filters which kind of universe we could possibly be observing. The observation is shaped invisibly by the existence of the observer. This way of thinking grows more natural still if our universe should turn out to be only one among a great many, a vast ensemble of universes, each born with its own settings of the fundamental dials, most of them sterile and dark, a rare and scattered few of them hospitable. In such a picture, it would be no miracle at all that we find ourselves in a hospitable one. It would be the only kind we ever could inhabit, the way a fish, if it could think, would find itself always and only in water. But I want to be very honest with you here, because the honesty matters. The existence of those other universes is for now entirely unproven. No one has ever observed another universe, and it may be that no one ever can. This is a frontier idea, sitting right at the edge of what we are able to test, a way of framing the mystery, not a settled answer to it, and thoughtful people disagree about all of it. Some suspect these constants are not truly free to vary in the way the puzzle assumes. Some believe we badly underestimate how many different kinds of universe might harbor some form of life. Some think the whole puzzle quietly dissolves when examined closely enough. The plain truth is that fine-tuning remains a genuinely open question, unresolved, perched at the boundary of what we understand. And yet, whatever the answer turns out to be, there is a quiet vertigo in simply standing here at all. A small, warm, breathing creature on a small blue world, gazing up at a cosmos whose very deepest settings happen, for whatever reason, to permit your gazing. To exist at all is to be, in some sense, exquisitely improbable, balanced on a ledge you did nothing to earn, and held there, gently, by numbers you will never see. So let that be the stillness you sink into now. The dark sky overhead, scattered with its uncountable stars. The few precise and silent numbers humming beneath everything that is, holding the whole cosmos in their narrow embrace. And you, small and alive beneath it all, looking up from your warm and quiet dark, improbable, held, and exactly able to wonder. Some years ago, scientists set out to repeat their own most celebrated experiments, and to their alarm, a great many of the results simply vanished. It was an unsettling thing to discover. Finding after finding, some of them famous, some written into the textbooks, refused to appear again when the studies were run a careful second time. The effect would shrink to nothing, or fade away entirely, or stranger still, reverse direction. And as the failures piled up across psychology and parts of medicine and beyond, scientists were forced into a hard and humbling reckoning with how much of their own published past they could actually trust. It came to be called the replication crisis, and it shook the field to its roots. At the very center of the trouble sat a single small, badly misunderstood number. Most experiments lean on a quantity called the p-value, and over the years a custom had hardened into something almost like superstition. The treating of one particular threshold as a magic line. Cross it, and your result was anointed significant, worthy of publishing and believing. Fall short of it, and your result was treated as nothing at all. A dull non-event to be filed away and forgotten. So much rested on which side of that one line a number happened to fall. But the p-value answers only a narrow and slippery question, and it is worth understanding exactly which one. It asks if there were truly no real effect here at all, if nothing whatsoever were going on. How surprising would data like this be? A small p-value says, in effect, this data would be quite surprising in a world where nothing is happening. And that is a genuinely useful thing to know. The quiet catastrophe was in what people heard it to mean. A small p-value does not tell you that your hypothesis is probably true. It does not promise that a real effect exists. It measures only the surprise of the data in a world with no effect. And minds hungry for certainty quietly, eagerly, mistook that for proof of the thing they hoped was real. And from that one misunderstanding, two quiet traps opened up. The first is that if you try enough things, enough slightly different analyses, enough ways of slicing and re-slicing the same data, some of them will eventually stumble across that magic line by pure chance alone, the way a slot machine will eventually pay out if you simply keep pulling the lever. The second is that the journals, drawn to the exciting and the new, mostly printed the bold, positive findings and quietly set aside the dull studies that found nothing. So the published records slowly filled with lucky flukes, while all the sobering silences, the many times an effect failed to show up at all, went unrecorded, and the world never saw them. Out of all this grew a different and quieter argument that science had, in this one respect, been asking the wrong question all along. Instead of asking only how surprising the data would be if nothing were going on, perhaps we should ask the fuller, wiser question. Given this data, and given how plausible the idea was to begin with, how much should we actually believe it now? That second question gently folds in something the magic line ignored entirely: the rarity of the claim itself. A wild and unlikely hypothesis, it says, should demand far stronger evidence before we believe it than a modest and expected one. Extraordinary claims, to earn our belief, must clear a higher bar, and I want to be clear, because it matters. This is a real and ongoing reckoning, still unfolding even now, and it is far more a sign of health than of sickness. A field that can turn around, examine its own proudest results, find many of them wanting, and say so plainly, out loud for all to hear. That is not a field falling apart. That is a field doing the bravest thing a seeker of truth can do. For there is something quietly noble buried in the whole painful episode, easy to miss beneath the worry. The deepest strength of science was never in being right the first time. It was in the willingness to test itself, to run the experiment again, to doubt its own conclusions, to discover its own mistakes and confess them. To turn that cold, honest gaze upon your own most cherished beliefs and let the evidence overturn them if it must, is its own rare and difficult kind of courage. So let this image settle softly over you, a quiet laboratory in the small hours of the night, an experiment patiently set up to run just one more time, and the simple, humble willingness to look again, the slow, honest, self-correcting heartbeat that is, in the end, science's truest and most enduring gift. Imagine a mind that begins with almost no leanings at all, save a single quiet love of simplicity, and that learns the truth about any world faster than any other mind ever could. It sounds like a fairy tale, and yet mathematicians have actually defined such a perfect reasoner, precisely, on paper. They have written down, in exact terms, what it would mean to learn in the best possible way, to draw the soundest conclusions any thinker possibly could from whatever the world reveals. It is the shining ideal that every real learner, every scientist, and every curious child, and every clever machine is only ever clumsily approximating. And in the very same breath, those mathematicians proved something stranger and more humbling still, that this perfect reasoner can never actually be built. It can only be approached, drawn nearer to, and never, ever reached. Let me show you gently how such a mind would think. Picture it facing a stream of information flowing in from the world, the rising and setting of distant lights, the unfolding of some long pattern, any sequence of happenings at all. To make sense of what it sees, it does something almost unimaginable. It holds in mind every possible explanation at once, every conceivable story that could account for the data. But it does not treat all those stories as equally likely. From the very start, it leans quietly and deliberately toward the simpler ones, the shorter, tidier, more elegant explanations, and it regards the convoluted, baroque, endlessly complicated ones with deep suspicion. The more elaborate and contrived a story must become to explain what is seen, the less this perfect mind is willing to believe it. And then, as each new piece of information arrives, it updates, smoothly shifting its confidence among all those countless explanations and converging with an almost eerie swiftness on the true pattern humming beneath the surface. This is, at heart, an old and familiar human intuition given perfect mathematical form. For many centuries, thinkers have felt in their bones that when two explanations fit the known facts equally well, The simpler of the two is the more likely to be true. A principle often called Occam's razor, after a medieval thinker who urged us not to multiply our assumptions beyond what is needed. We reach for it constantly, often without noticing. The perfect reasoner takes that gentle intuition and builds it into its very foundations, not as a vague preference, but as an exact and measured weight. The simpler the explanation, the greater the belief it is granted before any evidence even arrives. You lean on this very intuition yourself every single day without a moment's thought. Come downstairs to find a single set of muddy footprints leading straight to an open biscuit tin, and you do not seriously entertain an elaborate tale of cunning intruders who slipped in, took one biscuit, and slipped away again, leaving no other trace at all. You reach, instantly and rightly, for the simplest story that fits the facts. A hungry child, a quiet kitchen, a small moment of temptation. The simpler explanation is so very often the true one, and some patient part of you has always quietly known it. And now the beautiful catch. The reason it forever slips beyond our grasp. To do all of this truly perfectly, the reasoner would have to consider infinitely many possible explanations and weigh every single one of them exactly with flawless care. That is a labor no machine, however vast, and no mind, however quick, could ever actually complete. It would demand more computation than the entire universe could ever supply, more time than will ever exist. And so it remains, always, just out of reach. A perfect light gleaming on the far horizon, a thing we can define with total and absolute precision and yet can never construct. Real learners like you and me, and even our most powerful machines, can only ever sketch rough, partial, stumbling versions of it, chasing after it across the dark without ever quite arriving. There is something quietly beautiful in possessing a perfect thing you can never reach. It means we are able to define, with complete exactness, the ideal way to learn about reality, to hold the very shape of perfect understanding clearly in our minds, while knowing at the same time that we will only ever approximate it, draw near to it, fall a little short of it forever. And somehow that does not diminish the striving, it dignifies it. It makes every honest act of understanding, however small and partial, into a real step taken toward a perfection we can see shining clearly ahead and never quite touch. So let this last image carry you softly down. A single steady light far off on the dark horizon, the perfect reasoner, simple and luminous and forever out of reach. And all of us, every wondering mind that has ever tried to understand anything at all, walking slowly toward it through the night, never arriving, always with each patient step a little closer. One sweeping idea holds that everything alive stays alive by doing a single thing, quietly resisting surprise. It is among the most ambitious thoughts in all of science, and I offer it to you as exactly that, a grand and beautiful attempt to explain life itself with one principle, admired by some and doubted by others, and very far from proven. The idea runs like this. From the tiniest single cell to the largest and most intricate mind, a living thing persists by carrying within it a kind of model of its world, a quiet web of expectations about how things are and how they are likely to go, and by working endlessly to keep the gaps small between what it expects and what it actually finds. To be alive in this view is to predict the world and to keep on being mostly right about it. Let me unfold that slowly, because it is gentler than it sounds. Picture a single cell. It expects a certain warmth around it, a a certain balance of chemistry, a certain steadiness in its surroundings, and it acts constantly to keep itself within those expected bounds. It draws in what it needs and pushes away what it does not. It holds itself together against a world that is forever trying to wash it into disorder, to cool it, to dissolve it, to scatter its careful arrangement into nothing. Now scale that humble striving all the way up. A creature, too, carries expectations about where its food can be found, where danger tends to lurk, what the next moment is likely to bring, and it moves through its life forever, trimming the difference between what it anticipated and what actually arrives. Surprise, in this whole way of seeing, is the very thing all living things quietly labor to avoid. Not the delightful surprise of an unexpected kindness, but a deeper kind, the surprise of a world that no longer matches your model of it, which is only another name for danger, for being lost, for beginning to come apart. And your own mind, in this view, is the grandest such model of them all, a rich and living map of the world, built up patiently across the whole of your lifetime, tested again and again against everything your senses bring streaming in, and adjusted gently and ceaselessly to fit. Everything you understand is a part of that inner map. Every expectation you carry, every sense you have of how things tend to go, is a thread woven into it. And the model is never quite finished. Each new face you meet, each unfamiliar room you step into, each small lesson the day quietly teaches you, is folded gently in, and the map is redrawn a little to make room for it. You are, in this way of seeing, always softly under construction. Never a fixed and finished thing, but a living understanding of the world, forever being revised by the very world it is trying to understand. And here the idea reaches, softly and tentatively, toward the very thing happening to you in this moment. Some of those who think along these lines suspect that sleep may be when the model quietly tends to itself, when the mind, freed at last from the rushing flood of incoming sensation, turns inward and goes back over its great map, smoothing it, simplifying it, clearing away the tangles and clutter of the day, keeping the whole thing from growing overgrown and unwieldy. And dreams, in this gentle and still unproven reading, might be something like the model running freely on its own in the dark, replaying its world, reshaping itself, rehearsing and testing its expectations with no real world there to push back against them. I must say plainly that this connection between the grand theory and the actual workings of sleep is a hopeful suggestion still being explored, not anything established. But it is a lovely thought to hold as you drift. For there is something deeply soothing in it, whether or not it proves true in the end. The thought that to be alive at all is to carry a small, patient, faithful model of the world inside you, and that even now, even as you let go and sink toward sleep, that model is not simply switching off. It is softly tending itself, sorting through the day you lived, smoothing what you learned, quietly setting your inner world back in order, and getting you ready, in its gentle and tireless way, for the morning that will come. So let yourself be held by that. Let the day's 1,000 small impressions settle slowly into their places. Let your mind do the quiet, ancient work it knows so well how to do, asking nothing of you now but rest. You are in good hands tonight, your own, sinking softly into the care of your own dreaming, ordering, ever-patient mind, as the gap between you and sleep grows smaller and smaller and closes. And so, gently, we come to the end. If you have already drifted off somewhere along the way, then these last few words are not really for you. You are exactly where you were always meant to be, and I will only wish you well and let you sleep. But if you are still here with me, still awake in the quiet, there is no need to let the stillness break. Another journey is waiting whenever you should want it. Another slow wander through some beautiful mystery, ready to carry you the rest of the way down into rest. Let it begin the moment this one ends, and keep the quiet of the night unbroken. For now, let your thoughts grow soft and slow and easy. Let the day, with all of its small surprises, settle quietly into its place behind you. There is nothing left to solve tonight. There is nowhere else you need to be. Rest well, my friend, and sweet dreams among the stars.